Hello everyone. Today we'll be solving the problem number 167, 2 sum 2. So uh, we have already solved 2 sum problem, right? So today we'll be solving 2 sum 2. So you can just go through the problem and you can just go through the examples as well. So I'll just summarize the problem for you so that it will be easier to understand, right? So what the question states here, we are given an one indexed sorted array. So you can clearly see here we have given an one indexed sorted array numbers and the target value. We have been given the target value as well right here. The task is to find the two distinct numbers in the array such that their sum is equal to the target. So here you can clearly see 2 plus 7 is equal to 9. So we have to find the two distinct numbers in the array such that their sum equals to the target. The solution must return their indices as this one. Index 1 comma index 2 incremented by 1 because the array is 1 indexed here. You can clearly see the index doesn't starts from 0 here. The index starts from 1. So basically here 2 and 7, this the index is 1 and here this one 7, the index of the 7 is nothing but the 2. So that's what we have to display the output in the array, right? So the input guarantees that there is exactly one solution and we cannot use the same element twice. So we cannot make use of the same element twice and there is exactly one solution that we have to keep in mind. So initially let's discuss the approach, then let's go with the edge cases and then write the code, right? So let's discuss the approach. So let's discuss the approach step by step. Initially, let's go with the initialization, right? So let's go with the initialization part. So what we'll be doing here? So we will consider two pointers. One is left and one is right. Left at the beginning of the array. So I'll just consider here left at the beginning of the array. So I'll just give here beginning of the array and right at the end of the array. So here this has to be this is nothing but index 0 here. Left at the beginning array means beginning of the array means here index 0, right at the end of the array. So here I'll just give end of the array, right? This is nothing but numbers dot length minus 1. I'll just give here end dot length minus 1. Nothing but the last index, right? So what will be the logic? Let's move to the logic part. Nothing but the second step here. We have to compute the sum of the elements at the two pointers, right? So this, let's consider this one equals sum equals numbers I'll just consider n here, numbers of left plus numbers of right here. This is fine. We'll be considering this one. So what are all the things that we need to consider here? Let's go one by one, or let's go step by step. If sum equals target, then what we will do? We will return left plus 1 and right plus 1. Why we will return left plus 1 and right plus 1? Because we have to adjust for the 1 based indexing, right? This will be left, I'll just consider L, and right I'll just consider R here. Left plus 1 and right plus 1. This is one thing that we need to remember here. What we are doing, we have to compute the sum of the elements at the two pointers. Nothing but sum equals numbers of left plus numbers of right. So first condition here is if sum equals target, we are returning left plus 1 and right plus 1. Why we are doing plus 1 here for left and right? Because we have to adjust for 1 based indexing. This is important. So let's move on with the next thing. While sum is, we saw while sum equals target, we will be returning left plus 1 and right plus 1. When sum is less than target, what we will do here? This is the second thing, right? So what we'll do when sum less than target, we will increment left pointer to increase the sum. We will increment the left. This is second, this one condition. And when sum is greater than target, then what we will do here? We will decrement the right pointer. When sum is this one greater than target, then we will be decrementing the pointer. These three things we have to keep in mind. First thing is we are computing the sum of the elements at the two pointers, nothing but this one, numbers of left plus numbers of right, right? first condition is if sum equals target, we have to return left plus 1 and right plus 1. And second thing is sum is less than target, then we are incrementing the left. If sum is greater than target, then we will be decrementing the right. So the final thing is loop condition, nothing but we will repeat the above steps until left is less than right. We will repeat the steps until left is less than right. That's what we will do. This is the approach that we'll be going with. Next, we'll be discussing about the edge cases. Then let's write the code as. So let's see the edge cases one by one. First is for the minimum length array. So here let's consider numbers. So input is 2, 7. So I'll just consider target this one 9. So the output will be here 1, 2, right? 2 plus 7 is 9. This is for the minimum length array. So let me write here minimum length array. This is the first edge case that we'll be dealing with. So let's move on to the next edge case, nothing but the negative numbers. So let me give here numbers. Let me consider let me give here -3, -1, 0 and 4. This consists of the negative values as well, right? We are dealing with the negative numbers here. So target, let me consider here -4, -3 and -1. When we add this one, this will be basically this one -4. Here also the output will be 1, 2. Here the output will be 1, 2 as well. Here also the output will be 1, 2. This is for the negative numbers. So this is the second edge case that we are dealing with. So let's move on to the third edge case. So let's go with the duplicates in the array. While I say duplicates in the array, let me consider here numbers equals 1, 2, 3. We have the duplicate number here. You can clearly see here, right? 2 is repeated twice. So the target here is, let me give 4. So the output will be as it is 1 indexed here, this starts from 1, right? 1, 2, 3. 2, 3 will be the output here. So 2, we are going with, just give me a second here. Yeah, this is fine. 2, 3. So the output will be here 2, 3, and we are dealing with the duplicates in array, right? So let me give here duplicates in array. So finally, let me do one thing. We will discuss about the array with large numbers. This is the last edge case. So we'll be dealing with the array with large numbers. So let me consider here numbers. So 100, 200, some random numbers here, 300 up to let me give here let me consider numbers itself, 400 and 500 until 500, and the target is 900. Let me give target 900. So it will be 4 and 5 here. We can clearly see 1, 2, 3, 4 and 5. This sums up to the target, right? 4 and 5. So the output will be 4 and 5. We are dealing with array with large numbers. So these are the 4 edge cases that we need to consider. I hope all the edge cases are clear. So I'll just come here. The first edge case is we are dealing with the minimum length array. Second one was for the negative numbers, and the third one was for the duplicates in the array, and the fourth one was for the array with large numbers. Next, what we'll do, let's start writing the code. We have already discussed the approach and we have discussed this one edge cases as well. Now writing the code will be easy. Let's start writing the code. I'll explain the code along with the code itself, while writing the code itself, right? So then we'll be discussing about the time and space complexity. Let's quickly write the code and discuss about the time and space complexity, right? So first step here is what we will do. We have to initialize the 2 pointers, right? So I'll just consider, as we had discussed in the approach, I'll just give here left to the first index, left 0, and let me consider right. Let's initialize right to last index, nothing but numbers dot length minus 1. This is simple, right? Next, let's continue. Until the pointers meet. The condition was, if you remember, while we discussed in the approach, it is while left less than right. So we have to continue until the pointers meet, right? So next, what we'll do inside this while loop, we have to calculate the sum of two numbers, if you remember. So I'll just give here sum equals nums of we have numbers, right? Sorry, numbers of left less numbers of right. This is fine. Next step is if the sum matches the target, nothing but we have already discussed, if the sum equals target, sum is less than target, and sum is greater than target, right? Sum is equal to the target, we have to return left and right. As it is one index, we'll be going with left plus 1 and right plus 1, right? That is first condition. How can we write, how can we articulate in the form of code? So I can just give here sum equals target. So just give me a second here, sorry. Yeah, if sum equals target, then what can I do? I have to just return here left plus 1 as well as right plus 1. Why we are doing plus 1 here? This is one indexed base. So we are giving left plus 1 and right plus 1. This is important. Just keep this one in mind. This is not 0 indexed. So the index doesn't start from 0 here. This is one indexed. You can clearly see the sum adds up to 9 here, 2 and 7. So the output is not 0, 1 here. The output is 1, 2. This is one indexed array. So we are considering left plus 1 and right plus 1 over here. So the next condition was, if sum equals target, then we'll be returning left plus 1 and right plus 1. Then we have to write if the sum is less than target and sum is right greater than the target. That also we had seen in the approach, right? So how can we write that? So if sum is less than target, I'll just go with the ternary operator, right? Sum is less than target, then let's increment the left as we had discussed. And if not, if sum is greater than target, then what we'll do? We will decrement the right. This is simple, right? So this is it for the code. Finally, we have to get the output in the form of array. We'll just return within the array, right? So we'll just return the empty array here. So basically what it does, this guarantees the input, this guarantees the solution, basically this one, right? Whatever we are returning empty array, this one, this is fine. So this is it for the code. So let me run the code once. So you can clearly see the sample test cases are getting passed. Let me hit the submit. So this is fine. This works absolutely correct. So let's quickly discuss about the time and space complexity as well. The approach that we are going here is going with is this one, 2 pointers. We can clearly see here. What is the time complexity here? The overall time complexity here is big O of n. Why the time complexity here is big O of n? Because the algorithm makes a single pass through the array. We can clearly see here. The algorithm makes the single pass through the array, adjusting one pointer at a time. So here the algorithm makes a single pass through the array, adjusting one pointer at a time. So the overall time complexity would be big O of n. And what would be this overall space complexity? The overall space complexity would be big O of 1. Why here the space complexity is big O of 1, not the big O of n? Because no additional space is used, only pointers are maintained here. You can clearly see we are not making use of any additional space. We are just making use of the we are just maintaining the pointers, 2 pointers right here. So the overall space complexity here is big O of 1. I hope this is clear. So this is it. Thanks for watching, guys.